Now let us summarize the different parameters of hyperbola with respect to the two standard configurations, that is either a standard hyperbola or a conjugate hyperbola. Firstly, as far as the diagram is considered, here it's on the screen. For standard hyperbola, the two branches of the hyperbola open in either positive x direction or negative x direction, whereas in case of conjugate, the two branches open towards positive y-axis or negative y-axis. Right. The equation of the standard hyperbola we have already derived, that is x square upon a square minus y square upon b square equal to 1. So the only difference in the equation of the standard hyperbola and the ellipse, if you remember, is the change of sign. Okay, in case of ellipse it was plus, here it's minus. In case of conjugate, the right hand side becomes minus 1 instead of plus 1. The center for both the types of hyperbola is same, that is the origin, and which is same as the ellipse also. Then the vertices of both are also same. So the vertices are basically as shown here, the 2 points where the hyperbola cuts the transverse axis, and here we can nominate them as B and B dash. So these are the vertices which are at plus or minus a comma 0 for standard and 0 comma plus or minus b for the conjugate. Let's go ahead. Next we have foci. Once again they have the same expressions like we have for ellipse. So it's plus or minus ae comma 0 and 0 comma plus or minus be, and same is the case with directrices also. Again they have the same expressions like ellipse. Next we have transverse axis and conjugate axis. Now if you see, the expressions are exactly same as what we had for ellipse, but there we called the major and minor axis. Here we call them as transverse and conjugate axis. The expressions are exactly same. Then the relation between a and b. Now in case of ellipse, we had the term 1 minus e square, because in case of ellipse eccentricity is less than 1, but here it is bigger than 1, so therefore we have the expression e square minus 1, and rest of the format is same. Okay. So for conjugate also we have the same expression, except that we have e square minus 1. Then the eccentricity is given by this particular results. So once again the difference is that in case of ellipse we had the sign as minus inside the square root, here it is plus. Okay. Let's go ahead. Endpoints of latus rectum again have the same formula for their coordinates as in ellipse. Then the length of latus rectum also has exactly same formula like ellipse. So for standard and conjugate it's merely interchange of a and b. In case of focal distances the terms get interchanged. In case of ellipse it was a plus or minus ex1. Okay, here it is ex1 plus or minus a. That's the only difference. And in case of conjugate we have ey1 plus or minus b. Right? So in this way we can we can see that the expressions for different parameters of ellipse and hyperbola are very much similar to each other. We have to carefully remember where are the differences.